So there's f of t, there's g of t. What does this mean right there?
F. Wait,
In other words, there's another way to write that that's a little bit more clear.
it's like F parenthesis G parenthesis T parenthesis parenthesis.
Yeah, exactly. And the reason that's more clear is we see what g of t is. So what does this mean? F of what?
3t.
3 to the t power. Now we know how to do this. We take whatever's in the parentheses and we substitute it for t in the original f function. So what does that equal? Just at the moment, just substitute. Don't do anything else.
Log
Don't
3,
try to work
9.
out the math in advance.
Log 3, 9t times 3 to the t.
Hold on. It's not log 3 of 9t. It's log 3 of 9 times. Remember, wherever we see t, we're going to substitute 3 to the t power. Like that. See what I did? Very important that you see what I did.
Yep.
Okay. Now, says simplify completely. Well, I don't see any answers that look like that at all. So, first of all, let's see if we can simplify that. There is actually a way. Let's go over here on the left and write log base 3. It's another way to write the argument. Instead of 9 times 3 to the t, what's another way to write 9?
3 to the, or 3 squared.
Okay. Now notice that we have the same base, different exponents. What's that become? When I multiply same base, different exponents, what do I do to the exponents?
Add them. Or no, multiply them.
No, you're right.
Okay.
Never do the same thing that is being done to the base. If the base is multiplying, you're never multiplying. If the base is dividing, you are never dividing. When the base is multiplying, you're adding. When the base is dividing, you are subtracting. When the base is double exponentiating, then you're multiplying. But at this point, we have that. Now, notice the advantages of writing it like this. We have log base 3 of 3 to the 2 plus t. What's that equal to?
Just 2 plus t.
Now, why isn't that one of the answers? Because that's definitely 2 plus t. Well, glad you sent me an answer sheet. Let's take a look. Well, first of all, hold on. Before we do that, let me look and see if any of these answers are possibly 2 plus t. Notice number C. C is 3 times 2 plus t. Let's see. F of g of t is f of 3 to the t, which is log base 3 of 9 times 3 to the t plus 4. I get it. I simplified that, but I forgot the 4. There's still a plus 4 there. In other words, everything I did involved that. I forgot the 4 totally. Well, I still have the 4. You can't forget it. You have to add it to the final answer, and the final answer is t plus 6. Do you understand what happened?
Yeah.
Okay. Do you have your calculator in front of you?
Yep. Loading.
How are we going to solve this using the calculator?
Just put it into the graph.
Tell me more.
Put in log of 4 minus x.
Here's what you want to put in. What kind of calculator are you using?
Nspire.
Okay, the first function is log x. Second function is 4 minus x. The solution is wherever they cross. Go ahead and do that. And notice they're not asking for very much. They just want one of these 5 answers. So where do these functions cross? What's happening, Zach?
Putting it in.
Okay.
Says it's at 3.46 by 5.39.
3.46 is between those two numbers. Now, notice why that's not easy to solve algebraically. If I've got log of x equals 4 minus x, man, that is not easy at all. I can add x to both sides. I got log of x plus x minus 4 equals 0. There's just no way to solve that real easily algebraically. And it's because I have log functions combined with polynomial functions and constants. Actually, even without the constant, that would be hard to solve. Whenever you combine different kinds of functions, like say I had sine of x equals x. That's a trig function. That's a polynomial function. I'm not solving that any way that I know of. The only way I'm solving that is to put it into a graphing calculator and see where they cross. And that is the nature of number 9. Well, now here You might think the same thing, but not really. What we really have here is two exponential functions. In other words, e to the n is an exponential equation, or relate expression, and 3 to the n plus 2 is an exponential expression. So I might be able to do stuff like take the log of both sides. In fact, take the natural log of both sides. What happens?
Comes.
The reason I took the natural log is because when I see an e and I have to solve it by taking the log of both sides, I'm always taking natural log. Because the natural log of e is 1. So what's the left side turn into?
Just n.
Because natural log of e is 1. What's the right side turn into?
N plus 2.
Times the natural log of 3. Now, we're trying to solve for n. Well, what's our next step algebraically?
Divide by...
Hold on one moment. I made a mistake. I did not put that in parentheses, and they need to be in parentheses. In other words, I took the entire exponent and I put it down in front of natural log of 3. Therefore, it has to be in parentheses. So, what's the next step here?
Divide by ln of 3.
I'm trying to solve for n.
Divide by n plus 2.
That's all I'm going to get on the left side is n divided by n plus 2. That's not going to solve for n either. How about distributing? Remember what that is. That is a number. If I'd have said, instead of natural log of 3, if I'd have said 7, well, you'd have just multiplied it out. So let's do that. Natural log of 3 times n plus 2 times natural log of 3. So when I distribute it, now remember that is a number. This is not. This is a function. In other words, this is a variable here. So let's combine all of our like terms. With me?
Yep.
Okay. Now, that's a number. I can factor out n. What am I left with?
Minus ln of 3.
What's n divided by n?
1.
Is that not the answer? I mean, that's not the answer for n, but it's the next step in this equation. Now, what's n equal to?
You divide both sides by the 1 minus ln of 3.
So that should be our answer. Do we see anything like that? Now, on a problem like this, I don't ever even bother to look at the answers before I get the answer. In other words, number 10 does not help that it's multiple choice. The only help it gives you is that if you come up with an answer that is not on there, you know you made a mistake. But if after doing all the math, you come up with an answer that we did and it's on there, just check that off and go to the next problem. You know what I'm saying?
Yeah.
In other words, this is not one that multiple choice helps very much. You still got to solve it on your own. And it's hard. This is definitely a hard problem to solve. But we did, and then we check to make sure that our answer was one of the multiple choices. If it had not been, then I would have had to go back to the very beginning and check my math. I'd have had to go through the whole thing again. So that's why you check along the way. You don't want to wait till the end of the problem to check your math, because then you always have to go all the way back to the beginning.
That fighter jet was loud.
Was that what that was?
Yeah.
You got fighter jets going over you in Arizona?
Yeah, we have a base near campus.
Oh, really?
We have A-10s fly over all the time.
Huh.
And then today they got the F-18s flying a lot. So.
I lived in Vegas for 3 years, and Nellis Air Force Base was nearby. And so there were always jets in the sky. But in general, they didn't tend to fly over Vegas. Although I know that Nellis Air Force Base in Vegas is where they direct the drones all over the world. In other words, even the drones that they're, assassinating people with in Afghanistan are directed from Nellis Air Force Base.
Yeah.
Somebody's sitting at a desk and a computer.
Yeah.
In fact, they've always wondered about the psychological health of those people, because it's like they're playing a video game, only they're actually killing people. All right, let's look at number 11. All right.
Oh, and I also sent you right at the beginning of this lesson. I sent you a new study guide too for the new final as well.
Okay. Well, what do we want to do now? Do we want to continue on with this?
I mean, this will be on the test too, so yeah, we can.
Yeah, I think we should. Each of these problems seems to present something new in the way of a different type of math discipline needed in order to solve it. So that's helpful. That's the same thing as A equals PERT, in case you didn't notice it. In other words, this is the general formula for continuous growth. That's what they just gave us. The growth n of t is equal to the starting population times e to the r of t. So we're looking at the general equation that they were nice enough to give us. Now let's plug in everything. What's n of t?
Let's see, it'd be 246.7.
Yeah, I'm going to leave the million off because we're going to have million on both sides. What is n sub 0?
226.5.
Times e. They haven't told us what the rate is, but what do we know to be true about t with the numbers we put in?
That it's going to be, 10 years?
Yes.
Right?
So now we're looking at an equation that only has one variable. Do not be confused by the number e. That is not a variable, that is a constant. Okay? So, in other words, we can solve this by, whenever you're solving an exponential equation, that is where the variable's in the exponent, you inevitably have to use logs. That's the whole reason logs were invented, so that you could solve exponential equations. Okay? In order to solve an exponential equation, I got to isolate that first. So how do I do
that? Divide by 226.5.
Yeah, in other words, my goal here is to solve for r. Once I solve for r, then I'll have the specific equation that I can use a known r. Once I have r, that's all I need. Everything else I can figure out. So what is 246.7 divided by 226.5?
1.089.
That's equal to e to the r. Now let's put the coefficient in front. That's equal to e to the 10r. Now what's the next step? We have an exponential equation. How do I solve it?
You take the natural log of both sides.
Perfect. What's the right side become?
Be just 10r.
Left side is a number. So what's r?
Ln of 1.089 divided by 10.
There you go. What is that number? Now, let's go ahead and put a decimal on it, only because I'm looking at all the answers, and again, they don't want a specific answer, so I'm not worried about round-off error. In other words, that's actually the answer right there, if you wanted an exact answer for r. But if we get a number, it's going to make it a little bit easier.
So this gives us the rate, and then we have to plug it back in, right?
Exactly. What is this number here of what I have circled? What is that number?
0.0085.
All right. Now I'm going to erase everything, and we have our general, or rather, our specific equation. In other words, the whole point of the first part of this problem was to figure out r. They didn't give us r. But now we know it based on the information they gave us. So now I know that the specific equation is okay. And what do they ask? Assuming, what is the projected population of the U.S. in the year 2000? So fill in everything we know.
So the t is another 10, right?
Well, let's start off by that. That's what we're trying to solve for. What's the initial population?
246.7.
All right. We can use either one, but it's e to the 0.0085. What is t?
10.
And I could have used 226.5 and had a t of 20. Same thing. Would have given us the same answer. Now, it says, what is the population in the year 2000? Hold on. We did this a little bit strange, but that's okay. That's a number, right?
Yep.
You're going to be able to solve that with your calculator. But this is a little confusing. Let me go back for a moment. Let's do this a little bit different because it's confusing in the way that I did it. This is our specific equation right here. what they're really asking is what is n of 20, right? In other words, the year 2000 is 20 years after the initial population. So if I use the initial population, and now I can put e to the 0085 times 20. And that will give me the correct answer and is actually a little more understandable, I think. And again, we don't need an exact answer because they're giving us ranges here. Although I would go ahead and do this in your calculator and see what you get. Make sure that you get something that is one of the answers. Otherwise, it indicates you're doing something wrong, and we want to get to the bottom of it.
268.702.
And that would have been the same thing as n of 10, only my starting would have been 46.7 times e to the 0.0085 times 10. If you look up, this number should be the same as what you just got. Not that you need to do it, but just to let you know. In other words, I could use, because of the way they worded this problem, I could use 226.5 as the starting population with a 20-year period, or I could use 246.7 with a 10-year period. Both should give the exact same answer. All right. These kind of problems, you always want the general equation. The general equation is based on that right there. You have three general equations. Let's go over all three of them, just for a review. The first one is annual compounding. If you go to a bank and they tell you they're going to pay you 8% per year, that's the equation, where R is 0.08. That's annual. And then there is less than annual. In other words, let's say they're compounding quarterly or monthly. Well, that's more frequently than annual, and the equation changes. It's this one right here. Now, let's talk about that one. N is the number of times per year they are compounding. So in the question, they're saying interest is compounded monthly. So what's my equation going to be? In other words, it's not quite this general, but it's still general. It's whatever the initial amount is.
So 2,600, 1 plus, would it be 0.041?
Divided by what? How many times per year are they compounding it?
3.
12. It's compounded monthly.
Okay.
See that?
Yeah.
Matters a lot. You'll get an answer way out of bounds if you don't use the correct N. Now, determine the amount of time Okay, first of all, that's going to be 12t. In other words, this is the specific equation for this model. Right there. In other words, we know the r, we know the n. Notice that in this equation, the only thing that's a variable is t, because we know a sub 0. So if I go over here and I say, okay, a is equal to 2600, that's a sub 0, times 1 plus 0.041 divided by 12 to the 12t, that's the equation we need to solve. Well, not quite. This equation has two variables in it. I got to get an equation that only has one variable. So what is A? Determine the amount of time required to triple the value. So what does A have to be?
Be 3 times 2600, right?
Yeah, and I think that is 7,800. So here's what they're asking. How long does it take 2,600 to turn into 7,800 when compounded monthly at an annual rate of 0.041%? Notice that they always give you the interest rate annually. They don't give that to you monthly. Even though it's compounded monthly, that's an annual interest rate. And that's what R is in our equation, is the annual interest rate. So finally, we have an equation that only has one variable in it. It's the first step in solving that.
Divide 2600 to both sides.
What do you get?
3 equals 1 plus point, or yeah.
So 3 equals, what's this number going to be? Give me that on a calculator.
My calculator is dying, so I plugged it in. So.
Oh, it's tough to do sessions without you having a calculator, Zach.
1 plus 0.041. Yeah.
0.041 divided by 12. What is that?
So it'd be 1.00342, and then to the, what, 12? Or not?
Yep, to the 12t. So that's our equation we have to solve. Now we have it in a form where we can solve it by using logs. What do?
You put each side to log base 1.03.
Well, that's a hard way to do it, to be honest with you. I know that some schools teach that, but trust me, it's easier if you just always just take the natural log of both sides, regardless of what this number is, regardless of this base. And I'll show you why. The left side becomes natural log of 3. The right side becomes natural log of that. I now bring the 12t down in front, and I divide both sides by that number. And that's a number you can get out of your calculator. And then divide everything by 12. That's equal to t.
T equals 26.84.
Good. Now, the reason they're giving you ranges here is because they do want you to turn these into decimals. They don't want specific, exact answers. If they did, that's the answer right there. It's natural log of 3 divided by 12 times natural log of 1.003, whatever that number is, 42. Okay? So they don't really want this answer. They want a number, and they don't want you to necessarily have to tell you how many decimals to round it off to or anything. So they give you these ranges. So you can put it in one of those range. Relatively easy. Hold on. Okay, we have a whole bunch of problems on exponential functions. Notice that this number 13 is exactly that. Why? Because that t is in the exponent. That t right there. I know it's an exponential equation because of that. And I know I probably am going to have to use logs to solve it. So let's come up with the equation. That's the initial ozone layer. They want to know how long it will take for 70% of the ozone to disappear. So what's M going to be?
70%.
No, not if 70% is disappearing. How much is going to be left?
30%.
So we have 0.3 times the ozone layer amount. And let me just spell it out here because this isn't super clear yet. The initial ozone is this. They're saying it's e to the minus 0.0025 t. Correct?
Yeah.
Now notice that I can divide each side by ozone. And that's always the case when they give you these problems where they say, how long does it take to double or triple or quadruple or to go in half? It doesn't matter what you start with. Whatever you start with is going to divide itself out. In other words, if I divide both sides by ozone, I get this. Now solve.
And then you take the natural log.
Next line.
And then you would, it'd just be.
You do see that it does not matter what the ozone level was in the beginning, because that's always going to divide out. And in a lot of these exponential problems, that's true. If you say how long does it take to triple your money, you don't need to know a starting amount. That's all you need to know is the left side is 3 times a sub 0. The right side is a sub 0. The a sub 0s divide out. So what's the next line here?
It'd be ln 0.3 divided by ln of e equals.
Hold on. What's ln of e? What does this expression become? Using the rules of exponents. The idea is to get that variable down on the algebra line. We don't want it up there as an exponent. We can't solve it while it's an exponent. If we get it on the algebra line, we can use algebra to solve it.
Yeah, so 0.0025t.
Now,
And
what's
then
the
you
natural log of e equal to?
1.
Okay, so I don't need that. So what
And then
is
you
e
divide.
equal to? What's the exact answer? If they said this was not a multiple choice and they wanted the exact answer, what would your answer be?
Be ln 0.3 divided by negative 0.0025.
Yes. Now, one thing to know is that when you take logs of numbers between 0 and 1, you get negative answers. Always. No matter what the log is. No matter what base it is. So I know that when I take the natural log of 0.3, it's going to be negative, which is a good thing because I got a negative denominator. So, and I need t to be a positive number. It would be scary if t came out to be a negative number of years. What does t come out to be?
$481.589.
Number D. And the fact that they rounded it off doesn't matter. It's close enough, right? You said 481.9 something? Well, if we see an answer on there that's 482, that's close enough. All right. Finally, off of exponentials. That was like 5 or 6 problems on exponentials. So you know they're going to be heavy on the test on exponentials. Now we'll see how
they were.
Now we'll see how many problems are on trig. So,
Well, I already took that test.
okay.
I just took that test.
You can get that number out of your calculator. The only thing is your calculator gives you a decimal answer. Do you have a button on your calculator that converts decimals into fractions?
I have one that converts fractions into decimals, but not decimals into fractions.
Well, how would you do this problem then? Can you do it with do you have your calculator that has trig capability on it?
Yes.
Go ahead and do it. Tell me what you get. In other words, if you can use your calculator to solve this, more power to you. If it was up to me, I would not let you use your calculator to solve this. People are supposed to know trig enough that they shouldn't have to use their calculator on this. But if they're going to let you use your calculator, use it.
It's negative 0.5.
You didn't put it in right. Ah, yes you did. My mistake. Yes, negative 0.5. In other words, that is a third quadrant angle. So it's down here. And it's the same as pi over 6, which is 30 degrees. So it's the sine of 30 degrees, which is 1/2, but it's in the third quadrant, so we know it's negative. Because sine is only positive in the first and second quadrant. And this is in the third quadrant. But your calculator solved it for you. You didn't need to know any of that, as long as you had a calculator and you're able to use it. What kind of calculator are you using? Sorry?
N Spire.
Good. The Inspire has a secant key.
Yes.
Go ahead and use it. If you had a TI-84, it would not have a secant key, and this would be a harder problem. You'd have to know what was the invert or the reciprocal of secant. What is the reciprocal of secant?
Cosecant? Or no?
Cosine. So it'd be the same as the cosine of -3/4 pi. But since you have a secant key, go ahead and just put in everything you see here. What do you get for an answer? And if you get a decimal, tell me what it is. And then we just have to test which one of these answers equals that decimal.
It says it's -2.
We don't see one of those on there. So, let's figure out what the cosine of this number is. I can tell you what it is. It is +1/2. Here's how I know. Hold on. First of all, I know that cosine is the reciprocal. And where is that? That is in the third quadrant. So we know it's going to be negative. And your calculator gave you -2?
Yeah, -2.
None of these. In other words, the cosine would have been -2. But not the secant. Well, I don't actually know the cosine. I think the cosine would be -2 because that would be the same as 60 degrees, which is the cosine would be -1/2, which would make the reciprocal -2. So -2 is correct, and it's not on there as one of the answers. So it's none of those. In other words, you were able to do that with your calculator also. I'm a little concerned that you're going to get to the point where you think you can do all of these trig problems with your calculator, and then when they give you one that you can't do with your calculator, you're not going to be able to figure it out.
Bless you.
Excuse me. Sorry. Find the terminal point on the unit circle determined by the real number t equals 5π/6. Well, what they mean by that is that's the angle. They're giving us an angle there. That angle is 5π/6. Okay? So, if we take the sine of that angle, we will get the y-coordinate. If we take the cosine, we will get the x-coordinate. Let's be clear about that. That point right there is the cosine of theta, comma, the sine of theta. Every point on the unit circle is cosine of theta, comma, sine of theta, with theta being t. So take the cosine of 5 pi over 6. What do you get?
Negative 0.8866.
Learn to recognize that decimal. That is square root of 3 over 2. Square root of 3 is 1.7 something. So when I divide it by 2, I get 0.866. Now, is there any method on that calculator you're using to convert that decimal to a fraction?
Not that I know of.
Okay. Well, for the moment, let's just write it as you get it on your calculator. What was it?
Negative 0.866025.
We'll just write it in 3 places. What's the sine of 5 pi over 6?
One half.
Is that enough to answer the question? Let's see it. Takes away that, takes away that, takes away that, takes away that. The only one that has a y coordinate of 1/2 is that one right there. And square root of 3 over 2 is 0.866, so negative is negative 0.866. But they kind of made this easy. They didn't really make that as a criterion for solving the problem. Once you found what the sine of theta was, you had your answer because they only had one that had a y coordinate of 1/2. Hold on. Yeah, they did. That's the only one that has a y coordinate of 1/2. What's important is this. When you're on the unit circle, and that is theta, no matter what theta is, that point is cosine of theta, comma, sine of theta. Remember that, always. So let me test you. What's this point right there?
The square root of 3 over 1? No, 2.
That's the cosine of 30 degrees. What's the sine of 30 degrees?
Be 1/2.
Now notice that that's the common answer in trig. You get an awful lot of square root of 3 over 2. Notice that that is 0.866. So when you get a calculator answer of 0.866, you know it's square root of 3 over 2. If you get a calculator answer of 0.7 over 7, that's square root of 2 over 2. And in trig, we're used to doing these with the exact answer. We're not used to using a decimal. So you're liable to remember square root of 3 over 2, and then you do it in your calculator and you get 0.866. So make sure you know those are the same two numbers. Well, I don't know if we have enough time to do this one or not. I have another appointment, so gotta leave at 3. Well, let's just take a look at this one. We can pick up on this one next time if we don't finish it. This is going to be a long problem, so we're not going to finish it. But it's the same principle. In other words, this angle is what they're calling t minus pi. When they say there's a real number t, they're talking about an angle on the unit circle. Okay, just like the last time they were talking about that, and they called it t. Okay, they're really talking about an angle. So tell me what that coordinate is. If that angle is t minus pi, what's the coordinate? The x-coordinate is what? Cosine of t minus pi. Y-coordinate is what?
Sine of t minus pi.
Now, find the terminal point. I'm thinking. That's a second quadrant angle. No, it's a third quadrant angle. The second quadrant, we have 180 minus pi. In the third quadrant, we have pi minus 180. And what we have here is t minus pi. So this is a second quadrant angle. So cosine, what's the sign of the second quadrant for cosine?
Negative.
What's the sign of sine in the second quadrant?
Wouldn't it also be negative?
No, sine is positive. Remember, all students take calculus. Sine is positive in the second, tangent's positive in the third, cosine is positive in the fourth. Which means if it doesn't say positive, they're negative there. A means all are positive in the first. Well, we know we're in the second quadrant because of that. T minus pi is the way you kind of define the second quadrant, I think. I don't know, that's a puzzling question. But that to me means the cosine has to be negative, the sine has to be positive. That is the only answer that answers that. And I'll tell you what, next time let's check the answer on 17 to make sure that we were correct, and then we'll pick up from there.
Okay.
Okay, all right, Zach. We'll talk to you tomorrow, I think.
Yeah.
I'm not sure when your next appointment is, but I think you signed up for a couple of them this week, so.
It's either tomorrow or Thursday.
Here, let me check real quick so I can let you know. It is Thursday. Thursday morning at 11, not tomorrow. Talk to you Thursday.
Okay.
All right. Bye-bye.